Well, no, I always just like
And then you have a bruise on your forehead.
Painkillers?
I could have it.
I don't think there's
What's ahead of that? Please show me.
Yeah.
You don't supposed to bring those to school.
I just drink tea.
Take that.
Yeah, we gotta read the outside. Wait, don't we do something different on Monday? It's not Monday.
No, that was last year. We used to stems on
Andrew,
it.
you don't make me go all Kamari.
I'll see what
I don't want to read every day. Like, I
Let's
don't
see
like
how far we
I
can
don't
get.
like
Today, we're actually skipping 3.7 because
No.
honestly, we will return to 3.7.
I'm scared right
No,
now.
I did not like the way 3.7 looked. So we go to 3.8, we'll come back. So, I apologize in advance for 3.8. I think you'll like 3.8.
What's the G stand for?
Take a look. Alright. Did you do that on purpose, Ike?
I didn't. Fight.
Literally held onto the paper as he handed it to me, like, don't ingest it. Alright, take a look here. Sorry. No. Graphing absolute values. Think about this. I am first of all, I'm going to make a graph here. Think about this. Okay, this is my equation that I'm graphing. Again, do not forget, really it means this. This is exactly thinking like y equals the absolute value of x. You can think about it like that, but we say it as the function of x equals the absolute value of x. Give me a couple values to put in for x. I'm going to start off with 0. Something easily, Liam, give me a number for x. 2. Somebody give me a negative number that's within reason. Lucy, negative something. Negative, thank you for being consistent. And then let's just go, David. Negative 4. And for I'm going to add one more here and put a positive 4 there. If I plug all of those into my equation there, okay, g of x equals absolute value of x. Remember, if you're writing this out mathematically, like math people would like you to do, I'm putting 0 in for x, so the function g of 0 equals the absolute value of 0, so g of 0 would equal what? What is the absolute value of 0? 0. Because absolute value just makes everything positive. So my first point I'm going to plot is 0, 0. Tough one. If I put positive 2, g of positive 2 equals the absolute value of positive 2. What is the absolute value of positive 2, Reagan?
2 and negative 2.
No. What's the absolute value of positive 2? It's just 2. Absolute value just makes everything positive. So my next point I'm going to graph is 2, 2. What if I put negative 2 into that? G of negative 2 equals the absolute value of negative 2. What is the absolute value of negative 2?
2.
One more time.
2.
I can't hear you.
2.
So here at negative 2, it's also 2. Ooh, what in the world is that? Is this linear, by the way? No, won't form a straight line. And then negative 4, let's just do it. What is the absolute value of negative 4? 4. Positive 4. What's the absolute value of positive 4? 4. So here at positive 4, I put a dot at 4. Here at negative 4, I put a 4. Okay, and I end up with, through the magic and mystery of mathematics, I end up with this lovely shape here. Which is a V, right? Wait, is nobody agreeing with me?
Yes.
Okay. Focus with me on just for a second. Anytime, Carter Reichert, you see the absolute value in a function, you will get a V shape. Anytime you see, if I were to give you this, and I'm not going to do this, let's say I just had an f of x equals 3 times the absolute value of x minus 3. If you see that absolute value symbol in there, you are going to get a V. It's just going to be at a different place because all probably good numbers. So get that in your mind. Absolute value gives you a V.
Absolute value gives you a V.
Okay, we call this the parent function. It's the parent of this. In other words, if you stripped all the numbers away, you're left with Mr. Parent there. Okay, now, looking at what happens down here to this, you know what, let's just for fun review this here. Let's look at the domain and the range of this. The domain, which is what can x be? Looking at what can x be, who thinks they got an idea of what x values could be? Sam?
4.
Well, certainly 4 is one of them. But what else could x be? Kabari?
X can be less than -4, greater than -4, less than 4.
Let me ask you a question, Kabari, from my heart. What number could not x be?
Oh, it can be
So x, the domain of x is all real numbers. Why? Because it goes on forever. The x-axis is this one, and the x values are the straight up and down, and it goes on forever. Now, the range, however, is not that way. Why? What can't the range be? Well, the range would never be, it never is going to cross any of the y-axis down here. So how do I write out what y can be? Besides Kabari, who thinks they know what y could be? Besides Kabari, Anna Weiss, y would be greater than or equal to 0. Give Anna the biggest hand in the world, because that's not, yeah. That's not much of a hand. All right, it means, right here, y can be anything bigger than 0. It will go on forever that way, but it will never be anything down there. Congratulations to all of you that did it. Hopefully you catch that. We're going to get this, ladies and gentlemen. I can't change that. All right, now, let's see what happens to our V if we start throwing some numbers at it. All right, I'm not going to spend a lot of time, but you should be able to figure this out. What if I put 0 in for x? What would my g of x be there?
0.
No, because I have 0 plus 3.
3.
Let me, maybe you are hard of seeing and can't see this. Okay, g of x, I put 0 in for that, I end up with a, oh boy, no, please don't. Oh, that's fine, I can deal with that. So this is 3. I put a -2 in for x. What does that give you?
5.
David, what are we saying? Look, if I put -2 in for this, it makes it +2. What's +2 plus 3? 5. However, saying, does anybody, are people not seeing that?
I see.
If I put a +2 in for that, absolute value of +2 is +2, +2 plus 3 is
5.
5. If I put, let's do my -4. If I put -4 into that, absolute value of -4 is +4, and +4 plus 3 is 7. What if I put, let's do the next one and do +4. +4 would give me 7 again. Stop me there. You want me to go over that slower again?
Yes,
Yes.
All right, let me pretend I'm putting -2 into this. So here we go. G of -2 equals the absolute value of -2 plus 3. What is the absolute value of -2? +2. What is 2 plus 3? 5. That's where my 5 came from. The answer is going to be the same if I put a +2 in there, because it still is 2. 2 plus 3 is still going to be 5. Are you with me? Shall I do it again?
No.
I can talk it really super slow.
No.
It's pretty cool.
So, David, don't make me go there again, because I don't have any more hugs.
Okay.
So here's what it would look like. okay? 0, 3, negative 2, 5, positive 2, 5, negative 4, 7, which I guess we have to go up here just a little higher, and positive 4, 7.
We got the V.
Which gives me, now I'm going to do this kind of freehand simply because I want you to be able to see this. Which color should I use?
Green.
I don't like it, I'll try it again. Not bad. Okay. Notice what shape it is? A V. What has happened? It just did what? Think about the parent function was this. What effect did Mr. Positive 3 have on that? It just made it a horizontal shift up 3. It just went up 3 paces. Now, why is that important to know, you ask?
Why is that important to know?
Well, because of this, children, if you understand that small little concept there, you won't always have to do the little table thing, because if you know, watch, look, learn, and listen here. If I have the absolute value of x minus 2, guess what's going to happen to the graph of the parent graph? Instead of being here, it's going to end up down 2, horizontally shift by 2 down there. Okay, if it was the absolute value of x is negative 8 or minus 8, that means I would come all the way down here to the minus 8 side and do that. Now, let us speculate. Let's go to the second one here. Notice how this is different.
Oh no.
How is this different? This is different in that the number is along with the x and the absolute value sign. The other one was the absolute value sign and then it had the number outside of it. This one is inside. I wonder what's going to happen.
I do wonder.
I wonder what's going to happen.
I wonder what's going to happen.
That's what I like to hear. All right, so let's put some numbers in there. Again, going back to the ever popular, let's put 0 in there, negative 2, positive 2, 4, and negative 4. If I put 0 in there, 0 minus 2 is negative 2, and then the absolute value of negative 2 is 2. If I put negative 2 in there, negative 2 minus 2 is
0.
No, negative 2 minus 2 is negative 4, and the absolute value of negative 4 is 4. If I put positive 2 in there, 2 minus 2 is 0, the absolute value of 0 is 0. If I put 4 in there, 4 minus 2 is 2, absolute value of 2 is 2. If I put negative 4 in there, negative 4 and negative 2 is negative 6, absolute value of that is 6. Now, you want me to do that again slowly?
I got it.
Somebody say yes. 'Cause I think
Yes.
I said we and went with it.
Yes. Yes.
Here we go, ready? I will put negative 4 here. So, oh boy. So, you have the, wait, I'm sorry. What number do I need? What did I say I was putting in there? 4, right? I'm putting negative 4 in for M of 4. And that equals the absolute value of negative 4 minus 2. Put that over there. Well, negative 4, you don't take the absolute value, you should simplify the absolute value sign. Negative 4 and a negative 2 is a negative 6, and then the absolute value of negative 6 is positive 6. And that's what that is. Now, let's look at what happens. What's the shift when the number is inside the absolute value? We get 0, 0, 2. I get negative 2, 4. Negative 2, 4. I get 2, 0. I get 4, comma 2. And I get negative 4, comma 6. Wait, is that right?
Yeah, go back to the
Oh, I'm sorry, negative 4, comma 6, which is right here. Did I miss one?
No.
Okay. Can you see where the V is going to be?
Yes.
It's going to go ka-chunk, ka-chunk. Remember what the parent function was, which was this. If the number's in the absolute value sign, which way does it shift? It shifted
Who does that?
vertically.
Vertically.
Did it go vertically or
From
horizontally?
horizontal.
That was horizontal, the other one was vertical. Yeah. But here's the thing to remember, and we'll stop with this. Look, which way did it move? How many?
Both
2.
positive.
But this was a negative, but it moved
Positive.
positive.
Hmm.
Just keep that in mind,
My finger.
because it's going to be opposite of what the thing is you're watching. Why are you thinking that way? Let's look and see, what if I were graphing this? What if it was, and inside this I had x plus 3? Where is that graph going to end up? My parent thing is right here. If negative 2 moved it 2 places to the right, positive 3 is going to move it 3 places to the left.
Oh.
So it's just gonna end up here, at negative 3. Whatever this number inside there is. Now, are you ready to defy all odds?
Yeah.
What if we put both of those things together, and I gave you this equation? This is what you should write down. Let's say I have Q, why does it do that? What if you have Q of x equals the absolute value of x minus 1 plus 2? Do you need to draw the whole table? No. You just need to know what's going to happen to this parent function. What should we say? Well, if it's in here, this is the left or right number that it moves. If it's minus, it moves 1 positive. This one here, at the end, what does that do? That changes its up and down, so it's going to move from there and put that graph right there. So there's your graph without having to do any sort of a table. Everybody's happy, there's great rejoicing.
Yippee!
David and I don't need to hug anything out.
No, nothing.
Nothing. This all is what 3.7 is about, but I thought it was easier to see.
Yeah, it is.
I am going to stop sharing.
Thank you, Sarah.
I'm going to stop everything. And that is not going to buy any.